Hello everyone, it's Zenith20 again. In this video, we'll be adding the AI functionality to our Tic-Tac-Toe game. But before we get right into it, I'd just advise you to get the starter code for this Tic-Tac-Toe in the previously made video. I will link the previously made video somewhere above or maybe in the description, but make sure to have a look out for that because that's from where we're going to start today. So after you have had the basic code set up from the previous video of making a Tic-Tac-Toe, we can then start in the index.js. So let's get right into it. So the first thing we need to do to add a AI functionality to our game is that we're going to build around that functionality and we'll remove the player versus player. Maybe you can add it afterwards, but for the sake of simplicity and to reduce the amount of complexity, we're going to go for a full AI versus the player mode. So the first thing we're going to do is that we are going to add a board representation. So back here in the index.js, we'll create a board array, as you can see here. And in this board array, we are going to basically populate it with empty strings for now. What this will do is that it will keep track of the changes we make on the board. And this is crucial for the algorithm which we're going to use. So right now, if you see our tic-tac-toe, it's still the same. We have player versus player functionality, which I'm going to remove in a few minutes. All right. So when we have made the board representation, we now need to populate it and to keep the changes inside it. So in the button click function, we're going to add an extra line. First of all, let's go to the slot ID where we are defining our slot ID. Just below that, we'll make the slot index variable so that we can get to know what was the index of this slot. So we want first of all an array from buttons and we want the index of event.target. So we want the index of the event button which was click. All right. Now that we have this slot index, it's a number, we're going to populate our board with it. So whenever a player makes a turn, we're going to populate the board at that slot index with that specified symbol. So if it's player turn X, we'll add X to the board place. And if it's O, we'll add O. Okay. Next, we want to change the player turn. And we'll remove the check winner for now because we're going to add it in a different manner. Okay. So after this, that we have changed the player turn, we're going to add additional if condition below and we'll check if player turn is equals to X. So we'll do the AI move function, which we have not yet defined. So the AI move function will basically handle the searching of the best move it can make and then it will make that move on the board. So after we have called this AI move, we again obviously want to change the player turn. And yes, that's it. Okay. Check combination match will remain the same. Check winner, however, will change. We are going to change this function so that it is a pure function and it won't modify the UI in any manner. So to turn this function into a pure function, we are going to make this function return only three values, which is the player O1 or player X1, or if it's a tie, we'll bring out a tie. So for the first one condition, if the player 1 wins, we're going to return O because O won. And for the second one, we're going to return X. And for the third one, if there's a draw, we're going to return draw. Now you can see that all of this code has been dehighlighted, and we'll be basically moving this out of the function because we don't want our function to change the UI. Obviously, because our AI will work in such a way that it will have to access the board again and again and access this whole function again and again. So we don't want it to modify the UI as that is the internal work of the computer itself. So the very first thing we're going to do is we're going to go back to the button click where we commented out the check winner, and we're going to check for the winner. If we have a check winner, then we're going to check that if check winner is equals to X. So if check winner is equals to X, we're going to bring out the conditions. So if check winner is equals to X, we'll pull out the statements from the X statement in the check winner function, and we're going to put it here. Okay. Else if check winner is equals to O, then we're going to pull out the statements from the O's if condition, and we'll place it here. Lastly, we'll check for draw. So else if it's draw, or we can just add for check draw, we can add actually check winner. From check winner, we can find, yes. From check winner, we'll find if it's a draw. So we'll pull out statements for the draw. And that's it. We have moved all the UI updates into the event handler, which is the button click. And now our function is completely pure. So it's not manipulating the UI in any manner. It's just returning us pure string values. Now you can see that our check winner function is also utilizing another function inside of it, check draw. If we look at check draw, we are also manipulating the UI over here. We are checking from the buttons, but that's not what we are supposed to do. So instead of checking from the buttons for draw, we're going to check from the board. And in the board, we have just empty strings. So we're going to check board for each tile. And if each tile, or basically string, is equals to an empty one, then result is false. If any one of them is empty, we are going to return false, and that will not be a draw. Okay, so if we check back at our code, we can see that we're getting that our AI move is not defined. So let's get making that function. Okay, so we'll create the AI move function. It will take no parameters. And the very first thing we want to check is that we want to check if the game is over. Because if the game is over, we don't want our AI to start computing. If the game is over, we straight away return. Now, the next thing we're going to do is that we're going to go out of the AI move function, and we are going to create another essential function, which is find empty indexes. Basically, this will simplify the process for us to find all the available spots. You can name it find empty indexes, or you can name it as the find available spots. So find empty indexes will basically return us an array of numbers, and those numbers will be especially the indexes on the board, which will tell us which of these strings or which of these places are empty, and that can act as available spots for the opponent. So we're going to have an array of indexes, and we're going to loop over the board. So we'll add board dot for each tile. If tile is equals to empty, we want to add the index of it. So we'll add another parameter to the for each, and we will add indexes r dot push I. Okay. Now we can actually make our AI run at this point because we have this find empty indexes. Oh, make sure to return the empty indexes as well. So that's our function complete for find empty indexes. Now we can actually make our AI move at this point. So let's take board and let's try making a move with our AI first of all. So board find empty indexes, and this will return to us a list of positions, and we can actually console.log this to see that it's true. Find empty indexes. If you go back and do our O move, we can see that we have found the empty indexes, which are 1, 2, 3, 4, 5, 6, 7, 8, without the first one. If I'll do the middle one, you can see that the middle one is missing. If I'll do the 8th slot, we can see that the 8th slot is also missing. But currently you can see that there's another problem now because X is not doing the moves, so we can continuously do our moves. We're going to be fixing that in a minute. So once we have found the empty indexes, we are going to loop over all of these empty indexes. So empty index for each of these indexes. And before that, we're going to initialize two values, which will be let target score or let best score, in fact. Best score will be empty, or best score will be negative infinity, because the way the AI move will basically determine, it will use a minimax algorithm. And the minimax algorithm states that we want to maximize our chances for getting the best move and minimize the chances for the opponent to win. In this case, our AI is our player and the opponent is us. So it will take some time to understand it, and I'll explain it more in a minute. So we'll have let best score as negative infinity, and we're going to have target index as 0. So now over each of these empty indexes, we are going to do a complex thing. So first of all, the very first thing we're going to do is that we're going to take the board, and at the index, we are going to add X. So basically, for each of these indexes, we are going to add an X on the board, and we're going to add to the player 2 combo. Make sure it's a concatenation. So player 2 combo is equals to array.from buttons, and we're going to access the index of it, and we're going to take the ID. So basically, we are saying that, hey, this is the first move, so we're going to add the X at that index of the board, and we're also going to add the player 2 combo to it, because remember that our whole tic-tac-toe is based on these combos. So we're going to add the combo from the buttons array, and we're going to access at the index point, and we're going to get the ID. Next, what we're going to do is that we're going to get a score variable, and the score variable will have a function minimax. The minimax function will be passed two parameters, and the first one is the board, and the second one is the maximizing player. The maximizing player, I'll explain it in a minute. So these are the two values which you need. So the first one is the board, and the second one is the maximizing player, if it is a maximizing player. Okay, moving on. After we call minimax, we are going to reverse this move, because basically what we are trying to do over here is that we're going to go over each of these empty indexes or possible moves. We're going to make that possible move, and then our minimax function will get a score for us telling us how good this move is. So it will give us a quantitative answer of how good this move is for us or how good it is for the opponent. If it's good for the opponent, the score will be negative because it's the minimizer. And if the score is positive, it will be a good move for us because the X or the AI is the maximizer in this case. So the second parameter will be false. And then after the score, we are going to check. In fact, yes, after the score, we're going to reverse. So we'll copy this from above, and then we're going to remove the X from that position because we have to reverse it. We're just checking for the positions at that point. So after we have got a score from this recursive minimax function, we're going to call the board and we're going to change the index back to as it was. And from the player combo, we'll add to it player2 combo dot slice from 0 to -1. So basically, we're going to slice off the last character of it. So that's the reversed one. Now, lastly, we'll check if score is greater than best score. We are going to set the target index to 0. No, target index to index and best score to the score. Now you can see what's basically happening here. Why I kept negative infinity over here, because the score for the x will be positive. So no matter, even if the score is, for example, 1 for the specific position on the board, it will always be greater than negative infinity, because this is the worst case scenario for our opponent. Okay, that is the part done for the find empty indexes. Now we're going to head on to the minimax function. You might have to repeat this a few times to grasp it completely, because it's a recursive function. Okay, the minimax function takes two parameters. The first parameter is the board, and the second one is maximizing player. Wait a minute, is maximizing player. Okay. So now we have the board and the is maximizing player. We are going to now check first of all for the winner, because our minimax function will check until it will get to the terminal state, and we won't usually have a depth in this. Typically, we yes have a depth in the minimax because the minimax generates a game tree for us. So basically, it checks the opponent's move, and then it checks the responses for the opponent's move, and then it checks its responses to the player's moves, and so on. So it basically makes a game tree of the whole game. And Tic-Tac-Toe isn't a much big game with a lot of possible moves. Therefore, we're not adding a depth to it. Otherwise, if you want to improve the performance, you can add a depth to it to basically stop the minimax function if it reaches a certain depth of the tree. But for this case, we won't be adding a depth. Instead, we'll be adding the check for terminal state, which I'll explain in a minute. So we'll check if it is check winner. A terminal state in the minimax is stated as the possible game state or the board where the game is over. In our case, the game is over when X wins or when O wins or when it's a draw. So that's what we declare as a terminal state of the board. So first of all, we're going to check if there is check winner. If there is check winner, we're going to check if check winner is equals to O. Or we can either do this or we can either do this. We can check the combination match and we can check the player 1 combo along with, okay. So we'll check from the combination match for the player 1 combo. And if this returns us true, which I'm sure it returns that, yep. So we can either use check combination match or we can use check winner. All right. So we'll use check winner over here because that's a much more easier approach. We'll use check winner and we'll check if the winner is equals to O. So remember that O is our opponent and we want to minimize the result for the O. So if O is the winner over here, we want to return -10. Now this can be any value as long as it's in negative. Else if we want to check if check winner is equals to X. If it's equal to X, then we are going to return 10 because we want our AI to win, and our AI is X over here. Else if check winner equals to be draw. We didn't call the function. If check winner is equals to be draw, then we return 0. Now, this is an important part because this will allow our AI to always make a tie. Now, you can see in this case that our AI will not try to supposedly win, because in tic-tac-toe, it does not matter if the best move can even allow our AI to win. Our AI will search in such a way that it will try to get to a tie or a win. It will most probably favor a tie because that's obviously better than a loss, which you can see is -10. So it will favor a tie at least. Okay, that was the check for the terminal state. Now comes a bit of a tricky part, which is that we're going to loop over it recursively. So first of all, we want to check if it's a maximizing player. If it's the maximizing player, which is the opponent, we want to take our board and we're going to do the same process as we did above. So we can copy this. And we're going to paste it here. So we're going to check if the board, make sure we change this to lowercase. Oh yes, and we're going to actually add another variable. We're going to add let best score is equals to -infinity. And yes, we are going to then loop over the possible combinations. So find empty indexes, that is going to return us the possible positions. And then for each of the empty index, we want to loop over the index. So for each of the indexes, we want to loop over the index. So basically, we are saying that, hey, if it's the maximizing player, we want to take the best score as -infinity and then find all of the possible positions for this player and then try to simulate them. So basically what we're trying to do is that we make the move, we get the score for it, and then we reverse the changes which we have done. And then we store the score by doing this. We're going to write best score is equals to math dot, make sure math is capital. We're going to write math dot max best score and the score. So this will change the best score to whichever value is the max, which it is either the best score or the score. That's what the max function does. And for that's from where the minimax function's name came. So it says that we're going to keep on looping until we have a best score. And then in the end of this is maximizing player, we are going to return our best score. So this is one part of the function. We are saying if it's a maximizing player, take the best score as -infinity, loop over all the positions from that place, and then store its best score. So we want to store the best score, and then we return the best score. So it's basically a partial like backtracking because we're making the move and then we are iterating it with Minimax. So it goes each time deeper and deeper because we've made the move. It sends the board again. The function is called again, and then it sets again from here, and then it again loops over it and so on. So it goes deeper and deeper every time. Okay, that's one part of it. The second part which we'll have to do is for the player. So this is checking for the AI itself or the opponent. Second one will be for the player. Okay, now that was for player one. This will be for, that one was for player one, player two, and this one will be for player one. So make sure we change this to player one combo. This one is necessary, otherwise it won't work. We'll change this to O as well. And the best score is going to be +infinity because in this case, O is the minimizer and it will return the minimum score possible for it. The more negative the value is, the better score it will be for O and the worse it will be for X. So everything is same except for this one, math.min, because we want the minimum value of the scores. So the more smaller the value is, the better it is for our O player. That returns the score, and that is the minimax function in a nutshell. Okay, once we have the score, all right. Now we should have a target index calculated. So if we console.log the target index above, okay. All right, it is giving us 0. Okay, so what we have to do next is that we have the score and we've set all of this. But if we try running it, it does not give us the correct one. It's always returning the 0th position. That is not what we want exactly. Okay, so the problem is over here. We want to return true. Why? Because if it's the maximizing player, we'll do the turn for the maximizing player, and then we're going to search for our opponent's response to it. So this should be false. And likewise, if it's not the maximizing player, we want to do the turn for the not the maximizing player, and then check the score of how does the maximizing player respond to it, which is true. Then it will go here, and then it will go here back down. So up and down it shifts, and still seems to return a 0. Let's actually make this move on that position. So let's take the board, and we'll check target index. Board.target index is equals to, we're not going to check, we're going to assign to it, and we're going to write board.target index equals to x, and player 2 combo plus equals to the same array dot from buttons dot index id. This will be target index. Okay, I'm going to move this console log above. Okay, what else do we need? Pretty sure nothing else. Okay, so if we make the move, still not getting anything. Okay, we're still not getting any response. Okay, I get what's the problem. Oh my god. Okay, so basically we have nested this if maximizing inside the check winner. That's not what we're supposed to do. Make sure this check winner if condition is outside, and this is maximizing condition should be outside. So both of these should be separate. Keep a headouts for that. And now if we make the move, we are getting 4. Okay, 0. Nice. We are actually getting a response, except that there's still some problems. Okay, so what seems to be the problem is, yes, right here. We are changing the board to target x in target index equals to x. We are not checking for one fundamental thing. Let's actually separate this for the sake of ease. So first of all, we want the target button. So let's say target button is equals to array dot from buttons dot index. I'm doing this inside the AI move function. First of all, getting the target button. Next, we're getting the slot ID, because that is the letter. Slot ID is equals to target button dot ID. Now that simplifies stuff a lot. So we'll change the player to combo to be added with the slot ID. And the next thing is we get the target button, right? Now the target button's text content will be X. All right, that should be it. If we now check, we're getting a response. We are getting a response, and you can see it straight away went for that. All right, nice. And you can see that we're even getting the correct index over here. So if I remove the console log, and then if I try to do it, okay. Yes, it's doing it absolutely correctly. So let's see if it's undefeatable. So it's always going for the center. That's a really good strategy. Nice. Let's try for a tie, if it's possible to make a tie with it. So Let's do this. Yep, it's a tie, but look, can you see over here, we got another bug, which was it changed our O. Just see it again. Have a close look. Now, when I'll place the over here, the X is trying to add its move over here. And you can see that was a clear error. So what exactly was the problem is that we're not doing a check winner over here. Essentially, we're not doing a check winner over here. So we should better do that. And let's remove this part because the O comes after it. So it naturally does not make sense that we're going to add another one. This die works good except for the fact when we are trying to get from the corner, it changes that. So let's try fixing that bug. So to fix that bug, we can do one simple thing is that we can bring the check winner all the way up here. Or we can do one thing that we can do the player turn and we can do yes. And we can do and not check winner. So basically we're saying if its player turn is X and there is not a winner yet, then we do the AI move. This seems to make more sense. If we'll try to go for the corner. Okay. Let's do that again with a tie. Yes, that works. That works. And that's a tie again. So our AI, our computer is working pretty well. So that's it, everybody. That was the AI which we had added Tic-Tac-Toe. I hope you had enjoyed this video and hope you had understood the Minimax function. It was really a tough function. If you have any problems, you can comment down and I'll be eager to respond to them. Make sure to like and subscribe, and I'll see you in the next one. Goodbye.